Hello students, welcome back to Somshekhar class. Today I'm going to discuss about linear programming problem, which is very important from the point of examination, which is going to appear as 35th question in the annual examination problem. In this linear programming problem, we are going to find the solution for the equation for the objective function with respect to the subject to constraints and the positive inequalities. We are going to find the solution graphically. When we come up with the solutions, we may come across three types of solution, where that is bounded solution, that would be unbounded solution, or it would be no solution. This is the following LPP graphically. This question: minimize z that equal to 10x plus 5y, subject constraints 4x plus 2y less than or equal to 16, and another equation 2x plus 3y greater than or equal to 12, where positive constraints x comma y greater than or equal to 0. The question would be about minimization of z or maximization of z. So here I have taken minimization of z. Very first, using these equations, we have to obtain the ordered pair points, which we are going to use them to draw a graph. Using that, we are going to find the solution for the given LPP problem. Now let us solve these equations to obtain the ordered pairs. These are the equations which we are having, and this is the objective equation. Name this is 1, and equation 2, equation 3. Now using equation 2 and 3, we have to obtain the ordered pairs. So first let us consider 2. Equation 2 I am considering. So for the equation 4x plus 2y, here the inequality is there, less than or equal to 16. So we have to remove that inequality and we have to write it as equal to 16. Now first put x is equal to 0 in the equation. If I put x is equal to 0, 4 into 0 it becomes 0. Then 2y equal to 16. Y equal to 16 divided by 2, that gives you 8. So you should write this in the form of x comma y, where x is 0 and the point obtained and the value obtained is 8. Once you substitute x as 0, then put y as 0. Put y equal to 0. So when I substitute y as 0, 2 into 0, 0, I remain with 4x is equal to 16. And x equal to 16 divided by 4. 4 ones are 4, 4s are, so that equal to 4. And finally I got the point as 4 comma 0. Using the equation 2, I obtained 2 points, namely 0 comma 8 and 4 comma 0. Similarly, we have to obtain the points using the equation 2x plus 3y equal to 12. Consider 3. Right? The same procedure. Put x as 0. So it becomes 0. Then I remain with 3y equal to 12. Y equal to 12 by 3. That I got as 4. If I put in the form of x comma y, it becomes 0 comma 4. Similarly, put y as 0. So by that, I used to get 2x is equal to 12, x equal to 12 divided by 2, 1, 2, 6, I remain with 6. And in the form of x comma y, if I write, I used to get 6 comma 0. These are the 4 ordered pairs we obtained by solving the equation 2 and 3. Now using these ordered pairs, we have to draw graphs. So now using those ordered pairs, we have to draw graph. So what is the first point we are having? 0 comma 8. X value 0 and the y value 8, where it comes. So So here it comes, you just mark it and write down 0, 8. Afterwards, we are having the point 4, 0 in x-axis 4 and the y-axis 0. That is 4, 0. We are having it here. Once again, this is 4, 0. Once we locate the point, we have to join those points. So I can join that using a straight line. This is how I'm going to get the line. You just write that. What is the equation? 4x plus 2y equal to 60. Right? Now similarly, use another two ordered pairs and draw straight line. What are those points? Just locate them. 0, 4. Here it comes. 0, 4. And the last point 6, 0. Again, join those 2 points. And write the equation. What is that equation? 2x plus 3y equal to 12. So once you finish this, now you have to identify what is the solution region, where we are going to get exact solution using graphical method that we have to identify. Now you just look at the equation. What is the first equation? 4x plus 2y. The inequality what we are having is less than or equal to. And for third equation, 2x plus 3y, we are having the inequality is greater than or equal to. Whenever you are having the less than or equal to inequality, you have to shade towards the origin. Whenever you are having the greater than or equal to inequality, you have to move away from the origin. So the first equation is less than or equal to, hence I am going to shade that region towards the origin. So this is how it looks. Whereas the second equation is greater than 2x plus 3y. So I am going to shade with another color, with blue and pink, away from the region, away from the origin. This is how I am going to it moves away from the origin. And now the important thing is you have to select the region where both the equations intersects or meets. So by this graph I can identify this is the area where both the equations are meeting, right? By using this area, we have to mention the corner points. So this is, let us consider this as A, the first corner point, this as B, the second corner point, and here is the point C, this is the third corner point. Now take the x value, the corresponding x value, exactly it is giving me 3, where this exactly it is giving me the corner point as 2. Now we are having the 3 corner points A, B, C. Now you have to substitute the value of x and y, what you obtained in corner points, in the objective function. Which is the objective function? The equation 1. That is the objective function where you are going to substitute the values of x and y of the corner points, right? The 3 types of solution: bounded, unbounded, and no solution. So here all the corner points framed a boundary, so hence we call it as a bounded solution. Now let us substitute these values into the objective function. Now I am substituting the corner points in the objective functions. The first corner point 0, 8, if I substitute 10 into 0 plus 5 into 4, we get the value as 20. And the second corner point 0, 8, that 10 into 0 plus 5 into 8, I got the value 40. And the third corner point 10 into 3 plus 5 into 2, 10 into 3 30, 35 into 2 10, that is 40, right? Here we got the 3 values 20, 40 and 40 for the different ordered pairs. Now, what is our objective of the functions? So we have to minimization problem this is. So that means of these three values, we have to choose the minimum. So here the minimum value we are getting is 20 for the corner points 0, 4. So that is the solution for the given LPP. So here again, very important thing you can notice is here we are having the only one minimum value. If the same value repeated for twice, then the conclusion is different. Here, since we are having the only one minimum value, we are having unique optimal solution for the given LPP. Hence, you can write the LPP has unique optimal solution for x is equal to 0 and y equal to 4, the z value as 20. And if the objective function given as maximum, that is maximization problem, then you would have chosen 40 as its answer. And 40 is repeated for twice. Instead of writing the unique optimal solution, you would have written multiple optimal solution for the given LPP. This is very important from the point of examination, where it's going to be asked for 5 marks, definitely in the question number 35. I'll meet you in the next class with new concept.